Hello friends, welcome back to my YouTube channel. So in today's video we'll see one more problem of frame, how to analyze this by using the flexibility method. It is also called as the force method. In exam they may ask analyze the frame by flexibility method, force method or compatibility method. They can ask any one of this name. So this is the given frame. So as usual our first step is to find out in the DS, degree of static indeterminacy. So here it is the fixed end and here it is the roller support. It is BC is carrying the UDL of 20 kilonewton. So now we will find the DS. So for find out in the DS we have the formula 3m plus r minus 3j minus capital R, and here m is nothing but number of members and r is nothing but number of unknown reactions and j is nothing but number of joints and our r is nothing but number of internal hinge. So in this problem there is no any internal hinge, so it becomes 0. So here 3 into how many members? 1 member, 3, 1, 2, 3, 3 member, 3 into 3 plus how many number of reactions? Unknown reactions. Here at fixed support there is 3. One is vertical, horizontal, vertical, and movement is there here, and here only one, that is vertical, will takes place. Total number of unknowns are 4. So unknown reactions are 4. Here plus 4 minus 3 into how many numbers of joint? 1, 2, 3, 4. 4 number of joints. 3 into 4. So number of internal hinge, there is no internal hinge, so it becomes R becomes 0. So now solve it. So now we will solve it. 3 into 3 plus 4 minus 3 into 4. So it comes 1. Come out as 1 means the number of redundant in this structure is 1. To make it statically determinate structure, so we need to remove the 1 number of redundant. So the structure is now statically indeterminate. To make it determinate, statically determinate, we need to release the 1 number of redundant in this frame. So now I am selecting the support D to release the redundant. I am taking support D. Here I will give the vertical VD. So vertical load, it is redundant number 1. So call it as coordinate number 1 at point D. After taking the redundant, now we need to redraw the diagram, and I will read off first and then tell you. So this is the release structure of the redundant. This is point A, B, C and D. Here also point A, B, C, D. So now the structure is called the capital M and this is called the M1, moment of coordinate number 1. And now we need to apply the, here we need to apply the at point D unit load of 1 kilonewton. So that is nothing but the point where we have removed the redundant. At that point we need to apply the unit load of 1 kilonewton. At a time we need to apply only one coordinate. Frame only 2 diagram will come. Using these 2 diagram we need to find the moment. So we need to draw the unit load table. By using this diagram we will calculate the moment. So we need to draw the unit load table. So this is our unit load table. So like this our unit load table will come member, origin, limit, M, capital M and small m1. As I told earlier, to skip this calculation, I am calculating from this side to like this side. So if you want to calculate this reaction, then you can calculate from this side to this side. So I am now to skipping this reaction, I am calculating from this side to this side. That's why I am taken member of DC, CB and BA. So if you want to calculate the reaction of this, then you can calculate from this side also. So to save the time, I'm calculating from this side to this side. So that's why I'm have taken member as DC, CB and BA. So for DC I'm taking origin as D, and for CB I'm taking origin as C, and for BA I'm taking origin as B. So limit is C. For DC we have the length 3 meter, it means 0 to 3 limit, and for CB length is 3 meter, limit is 0 to 3, and here also limit 0 to 3. So now we'll see M1 for M. Now we'll see how to calculate the moment. For DC I have taken origin as D. So I have taken origin as D. It means we need to cut the section x-axis away from the origin D at a distance of x. From here to here is x. So here there is no any load, so our M becomes 0. Similarly for M1, if you cut the section x-axis away from the origin D at a distance of x, this 1 kilonewton is acting axial to this, so moment becomes 0. Moment becomes 0. M1 becomes 0 for DC. Now for CB, so I have taken the origin as C. For CB I have taken the origin as C. If you cut the section x-axis away from the origin C at a distance of x, so we need to see from here to here. So here there is no load, here the UDL is acting 20 kilonewton. If you convert UDL to point load like this, it acts downward. So upward we need to take the positive, and downward we need to take the negative. So it comes like this, downward we need to take the negative minus. So 20 into the value becomes minus 20 into at a distance of x into UDL always act at the distance of L by 2. L by 2 is nothing but our distance is here x, no, x divided by 2. X divided by 2. 2 1 ja, 2 1 ja. So it becomes minus 10 x square. M becomes for CB minus 10 x square. CB is minus 10 x square. Similarly for M1, if you cut the section x-axis away from the origin C at a distance of x, so here 1 kilonewton load is acting. So at what distance from this section, what distance it is acting, we need to see the perpendicular distance. The perpendicular distance of 1 from this section is x. So perpendicular from this section is x, so we need to take the perpendicular distance. So perpendicular for 1 kilonewton, so BC is perpendicular, we need to take this distance is nothing but x. So M1 is x. Now for BA, we have taken the origin as B. BA origin as B. If you cut the section x-axis away from the origin B at a distance of x, our capital M becomes, so we need to see from here to here there is one UDL is acting, so it is act. If you convert UDL to downward, it comes like this, means it is acting downward. Downward means we need to take the minus. So minus, I will write here. So minus 20 into at a distance of, so our BC distance is 3 meter at a distance of 3 into, so the UDL always act L by 2. Distance means 3 divided by 2. So simplify it. So it comes minus 90. For BA we have the value minus 90. So now for BA member, so origin is B. If you cut the section x-axis away from the origin B at a distance of x, so at what distance the 1 kilonewton is acting, so the perpendicular distance of 1 kilonewton is, so BC, no, so we need to take the perpendicular distance. For BC we have the distance 3 meter, no, so for 1 kilonewton we have the M1 value 3. So we always need to see the perpendicular distance. So perpendicular distance for BC is, it has a 3 meter. 3 meter means our M1 value is 3. So this is how we need to fill our unit load table. So now it becomes we have only one coordinate. Now for that our flexibility matrix becomes F11. So we need to find the F11. For that we have the formula integration of 0 to L m1 square divided by EI into dx. Now put all the value. Integration of for m1 is the, for dc we have the 0, so we don't need to calculate this. For cb we have the limit 0 to 3 m1 is x, so x square, here value is, I am taking here outside, 1 divided by a, it is constant, so x square whole square, sorry, only x square, so x square into dx plus, here also put the bracket here, you write here. So for behave we have the limit 0 to 3 and m1 is 3, so 3 square into dx. So now close the bracket. So now calculate it. So integration of 0 to 3 into x square plus integration of 0 to 3 into 3 square. So now solve it. Our f1 value will come out as 36. So f11 value is 36 divided by ei. Similarly we need to find the d11 also. For that we have the formula integration of 0 to L capital N M small m1 divided by ei into dx. Now put all the value. 1 divided by ei I am taking outside, 1 divided by ei, integration of 0 to 3. For DC value is 0, 0 into anything becomes 0. So for CB this into this one, and for BA this into this one. So minus 10 x square into x dx plus integration of 0 to 3 minus 90 into 3 dx. Close it. So now solve it. Our d1 will come out as integration of 0 to 3 into minus 10x square, close the bracket, into x plus integration of 0 to 3 into minus 90 into 3. So now solve it. Our d11 value will come out as minus 1012.5. So d11 value is minus 1012.5 divided by ei. So now we got the f11 and d11. So now we'll calculate by using this redundant value. So by using the compatibility equation, so P matrix is nothing but the whatever the redundant we have taken, that matrix of flexibility matrix universe dou matrix into displacement matrix. So now our P is nothing but the whatever the VD we have taken, that one. Similarly flexibility matrix is 36 universe, this matrix is value 0, the value is not given, into minus of DL matrix displacement we got was minus 1012.5, close the bracket. Now this is 1 into 1 matrix. Now we can calculate easily by using the calc. So now I will show. So the value is minus 36 universe, sorry, this plus 36 inverse into minus of bracket minus of 1000 12.5 close the bracket, again bracket, the VD value will come out as 28.12. It is positive. So VD value will come out as 28.12 kilo Newton. So it is upward positive means. So now you can find out these reactions. You can find out the vertical here at point A VA, and also horizontal one HA, and moment also. You can find out these unknown reactions by using these values. So I'm taking by using the static equation, summation of Fy is equal to 0. All the vertical forces we need to take upward, we need to take the positive. VA is here going upward, so VA plus, it is also going upward, 28.12. Here UDL, if you convert it into point load, it comes downward, so minus 20 into add. So if you convert this UDL to point load, it moves downward, so minus 20 into at a distance of 3 meter. 3 meter is equal to 0. So now solve it. Our VA will come out as 28.12 minus 20 into 3. So it comes minus 13.88. So if you take this to right side, it becomes positive 31.88 kilonewton. So upward. So direction whatever we have considered was right. Similarly for summation of Fx is equal to 0. So in this direction we need to take positive, in this direction we need to take the negative. So here there is no any horizontal forces, so our HA becomes 0. So we need to make it like this, in this direction. This direction we need to take positive HA. So similarly we need to find the moment. So I'm considering it as clockwise, summation of all the moment about point A is equal to 0. Clockwise when you take the positive, here it is moving, wait, the MA, considering positive means MA minus, it moves anti-clockwise, minus 28.13. the perpendicular distance of this is this one, 3 meter. So we need to see the perpendicular distance. So for 28.12 kilometer, perpendicular distance is BC has a length 3 meters, so 28.12 into 3 meter. So if you convert UDL to point load, it rotates like this clockwise, so plus 20 into at a distance of 3. So 20 into distance of 3, UD will always act at a distance of L by 2 means 3 divided by 2. 3 divided by 2 is nothing but 1.5 is equal to 0. So MA, calculate this MA. MA will come out as minus 5.64 kilonewton into meter. So it is anti-clockwise. So it rotates like this. So it means the direction we have considered positive clockwise. No, it is wrong. We need to make it anti-clockwise like this. It has the value of 5.64. So whatever the direction we have considered clockwise is wrong. So it is rotating anti-clockwise. So minus 5.64. So this is how we need to find all the reactions of this support. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.